Test review, volume and surface area. Number 1, what is the total surface area of the rectangular prism of the net shown below? So let's circle total surface area and prism. We can look at our math chart and find the formula for total surface area of a prism. It's right here. And we can use that formula. Or we can calculate the area of each one of these rectangles separately. So let's take a look at this rectangle here. The base has a length of 9 inches and a height of 10 inches. So the area would be 9 times 10, which equals 90 inches squared. So 90 inches squared is just the area for this rectangle here. Now let's move to the left and look at this smaller, or this more narrow rectangle. It has a base of 2 inches and the height is still 10 inches. From this point to this point, we have to look over here at this measurement and see that it's 10 inches. So the area is 2 times 10, which is 20 inches squared. Let's move over to this next rectangle, and we see that this rectangle shares the same characteristics as the rectangle that has an area of 90 inches squared. So we know that this area also has to be 90 inches squared. Let's go to the left again. Well, this rectangle shares the same characteristic as the rectangle that has an area of 20 inches squared. So we don't need to do any calculations. We just need to see that it's similar, and so it has the same area measurement. Lastly, and probably most importantly, we see that this rectangle has a measurement of 2 inches, but now we need to calculate what's the measurement from this point to this point. What is that length? Well, a common mistake is you're going to think that it's 10 inches, but it's not. We'll use this measurement here to see that the length is actually 9 inches. So 2 times 9 is 18, and therefore this area has to be 18 as well. And now with total surface area, all we're going to do is add up the areas of all the rectangles separately. So I'm going to start here. I have 20, I have 90, I have 20 again, I have 90 again, then I have 18 and 18, which makes 36. 0, 0, 0, 0 plus 6 is 6. 2 plus 9 is 11. 13, 22, 25. So we see that the total surface area is 256 square inches, or inches squared, means the same thing, which is answer choice C. Number 2. Gerard is building a rectangular patio measuring 12.5 feet long, let's circle that, and 9 feet wide. If the floor will be a cement slab 4 inches thick, how many cubic feet of cement will it take to build the slab? Well, cubic feet is very important because that tells us that we're solving for volume. And in order to solve for volume, we need to identify, well, what type of shape is this? Well, it tells you right here, rectangular. So let's circle that or put that in a rectangle as well, rectangular patio. So this slab, this concrete slab, cement slab, would have to be a rectangular prism. So take out your math chart. Let's find the formula for volume of a prism. It's capital B times H. Capital B times H. But as we know, I don't like using capital B because it really doesn't tell us too much. So let's change capital B to, if it's a rectangular prism, we know we can just use length times width times height. Okay? So we're just going to take these three measurements given to us in the problem, 12.5 times 9 times 4, and multiply those three numbers in any order. I'm going to just multiply first come, first serve. 12.5 times 9 is move your decimal one place because there's one number to the right of the decimal in the original problem. So that's 112.5, and now let's multiply that by 4. 4 times 2 is 8, plus 2 is 10. And again, move your decimal one place because there's one number to the right of the decimal in the problem. So 450 feet cubed would be your answer. That's the volume. That's how much cement you need to build that rectangular patio. Number 3, you have a square pyramid with the dimensions. Find the volume. We are always going to write the formula for whatever measurement we're solving for. So volume of a pyramid is right here. 1/3 area of the base times the height. So volume is area of the base times the height divided by 3. Means the same thing as taking 1/3 of it. So now we need to identify, well, what's the area of the base? Well, the base is right here. I'm going to shade it. It's a square. Tells you that right here. So I need to find the area of that square. So I'm going to use 3 times 3, which is 9. So now I'm going to plug and chug. Plug 9 in for B times the height. The height is always the measurement that starts at the middle of the base and goes up to the vertex. So 2 divided by 3 gives you 18 divided by 3. Now you divide and you get 6 meters cubed. Volume is always cubed. Number 4. Okay, great. Now we have an easy one that doesn't require any calculations. Which of the following nets represents a triangular prism? Circle it. Triangular prism. Well, we know that a prism that's a triangular prism has triangles on each side. Well, the only net that has triangles would be A. Number 5. Most of the time, if not all the time, when I see a shape drawn that has right angles, I know that I'm going to use Pythagorean theorem. So on the STAR test, they're not going to give you a hint that says use Pythagorean theorem like we did on the test review. So let's read the problem. The baseball diamond is a square with a side length of 90 feet. So let's write that into the picture, 90 feet. Each one of these sides is 90 feet. To the nearest foot, what is the distance between first base and third base? So we want to find this distance right here. Well, you can see that this is a, let's see, side length of 90 feet between first base and third base. So we need to reword this problem. What is the shortest distance between first base and third base? So we know that from first to second base it's 90 feet. From second base to third base it's 90 feet. So that's not the shortest distance to take. The shortest distance to take to go from first to third base would be this line right here. And notice that that line is opposite this right angle. This shape is a right triangle that is twisted somewhat. So we know the side of a right triangle that's opposite the right angle is always your C, and your C is called your hypotenuse. And your hypotenuse is your longest side. So I know that I can look at answer choice B and say it can't be answer choice B, because my hypotenuse cannot be the same measurement as a leg. I can look at answer choice A and say that's unreasonable. It's not going to be 810 feet between first base and third base. So now we're down to two answer choices. So let's do a computation. If I were to guess, I would probably say answer choice D is the correct answer. But let's go ahead and compute this. So we have 90 squared plus 90 squared equals C squared. 90 squared is 8,100. So we need to add 8,100, and you get 16,200. And now we need to take the square root. And what happens when you take the square root of C squared is the exponent goes away, and it becomes just C. The square root of 16,200 is 127.28. So we'll round it to 127, so answer choice D. Number 6. A car wheel is shown below. Which is the closest to the distance traveled during 5 rotations of the wheel? The wheel, each rotation is considered the circumference of the wheel. So one rotation equals circumference. So let's take a look at the math chart. So we have two formulas for circumference of a circle. We have 2 pi r and pi d. I like to use pi d. So the formula, always write the formula, equals circumference equals pi times diameter. We're going to round pi to 3. The diameter is given to us. It's right here. So 3 times 48 would be 144. However, it says 5 rotations. So the wheel has traveled 144 inches after 1 rotation. So after 5 rotations, it will have traveled approximately 720 inches. Now notice that there's no answer choice for 720 inches. Why is that? Well, that's because we rounded pi. Pi actually equals 3.14. So we rounded pi to 3. So our answer is less than the actual answer. So the actual answer would be A. Number 7. Mr. Rogers told his class that a certain rectangle has a perimeter of 20 centimeters and an area of 21 square centimeters. Which of the following could be the dimensions of the rectangle? So let's circle perimeter is 20 and area is 21. So let's look at the answer choices and work backwards. Well, I know to find the area of a rectangle, I just multiply the measurements. So 10 times 2 is 20. 8 times 2 is 16. 7 times 3 is 21. And 21 times 1 is 21. So I can eliminate C and A because the area does not match up to the area in the problem. Now let's calculate perimeter. Well, if I have a rectangle that's 7 by 3, what's my perimeter? Well, 7 plus 7 is 14, plus 7 is 17, 7 plus 7 is 14, plus 3 is 17, plus another 3 is 20. So the correct answer has to be D. You'll get an entirely different perimeter with answer choice B. Number 8. For small paving jobs, Billie Jean Whiskers III uses a hand help cement roller. To the nearest square inch, what is the area of pavement with which the surface of the roller will come in contact with in one complete rotation? So only this part of the roller is going to come in contact with the pavement, not the ends of the roller. So this is a fancy way for asking what is the lateral surface area. And we know the shape is a cylinder, so let's take out our math chart. And we see that the formula for lateral surface area of a cylinder is 2 pi RH. 2 pi RH. Now we're going to plug and chug. 2 times 3 times the radius. Well, the radius is 8. Times the height. Well, the height connects the two bases. This line right here connects the two bases. So the height is 30. Now we're going to solve this first come, first serve. 2 times 3 is 6. Times 8 times 30. 6 times 8 is 48. Times 30. And so now we need to do a computation here. 48 times 30. Let's see. Okay, so we have 1,440. Notice there's no answer choice with 1,440. Why? Because we rounded pi to 3. So our answer is less than the actual answer of 1,507. Number 9. A cylindrical glass vase is 6 inches in diameter. Let's draw that into the picture because it's not drawn for us. And 12 inches high. There are 4 inches of sand, so from here to here is 4, in the vase, as shown below. What is the volume for the amount of air that fills up the rest of the vase, not including the sand? So if the total height is 12, to find the height from here to here, we just take 12 minus 4, so that height is 8. So we're going to use that height because we're only interested in the area that fills up this portion of the cylinder. Another way to think of this is what's the volume of that portion of the cylinder? So let's take out our handy math chart, and we see that it's capital B times H. So volume equals capital B times H. Well, as you know from class, I don't like capital B because it doesn't tell us anything other than we know that it stands for area of base. So what I want to do is substitute the formula for area of the base. Well, the base is a circle, and the formula for area of a circle is pi times radius squared, and then the volume formula has that times the height. Now we're going to plug and chug. We're going to round pi to 3. The radius, well, the diameter is 6, so don't plug in 6 for the radius. The radius has to be half the diameter. And we're only interested, a common mistake is students will plug in 12 for the height. Well, we don't want the volume including the sand, which 12 includes that. We only want the volume of the air that fills up above the sand, so we're going to use a height of 8. PEMDAS says exponents first. First come, first serve. 27 times 8. You get 216. Now we have a problem because we have two answer choices, A and D, that are close to our answer. So let's go back to one of our testing strategies. Before we round or estimate, we need to look at our answer choices to see if we have any that are real close together. Can you see how these are really close together? So now we need to go back and actually use 3.14. So let's go back and use 3.14. So I'm going to change this to 3.14. So let's see. 9 times 8 is 72. 72 times 3.14. And I like to write the number with the most units up top. So 3.14 times 72, right? Because 9 times 8 is 72. Eight, 2, 6. Add a 0 before you multiply by 7. Okay, so I carried the 1. 1 plus 6 is 7. 7 plus 9 is 16. Two numbers to the right of the decimal, so I need to move my decimal 2 places. And I get 226.08. So there may be a typo on this review because I don't see an answer choice that's 226.08. So let's come back to number 9, but you get the idea. Number 10. A cube with an edge of 20 centimeters is filled with water. So here's my cube. An edge is 20. We know a cube has congruent edges. A cube has congruent edges. All the edges are the same, in other words. What is the amount of water fit in a, let's see. Would this amount of water fit in a sphere with a 20 centimeter radius? So here's my cube. Would this amount of water fit in a sphere? Well, picture there's a sphere inside this cube. So can I fit the same amount of water in that sphere as I can fit in the cube? The answer is no. Because notice that there's going to be some gaps between the outside of the sphere and the inside of the cube, so the cube is going to hold more, a larger volume of water than the sphere. And I'm just going to explain because there are gaps outside the sphere and inside the cube. So the cube will hold a larger volume of water. And if you want to prove that, we can. Well, what's the volume of a cube with an edge of 20? Well, volume of a cube is 20 times 20 times 20, which is, let's see, 400. So that's what, 8,000? Right? 20 times 20 times 20 is 8,000 centimeters cubed. Now let's use the formula for volume of a sphere. Volume of a sphere is 4 times pi times radius cubed divided by 3. Let's see, 4, let's plug and chug. 4 times 3. The radius, well, notice that this edge of 20 is the diameter of the sphere. So the radius has to be half of that. So the radius is 10. So 10 times 10 times 10. Well, 10 times 10 is 100. 100 times 10 is 1,000. 4 times 3 is 12. 12 times 1,000 is 12,000. Then you divide that by 3. And you get 3 goes into 12 4 times. And then add your zeros onto the end. So the volume of the sphere is actually half the volume of the cube. So the volume of the sphere holds considerably less water than the volume of the cube.